This talk that I will be giving now will have a slightly different spin to much of what you have heard previously today. So I won't be focusing so much on introducing new technologies and new developments, but you could say that the point I want to make is that you should make the most out of the technologies that you already have available today. And the example that I will use for that is to give a first-hand account of using REST API for automation from the perspective of an integration engineer. So you're all very familiar with the use of REST API for communication between applications, or if you have a pipeline, say if you have a need to use cryptographic keys in your application or in a workflow, you're probably using the Securysys REST API to do so. But from the perspective of an integration engineer myself, I'm not a developer, I will give you an example of instead using the REST API capabilities of the application that I'm mainly working with, that we're developing, for configuration management and streamlining deployments and taking away the manual work and the work that used to be done by me manually and improving it with the help of REST. So first of all, as introduction to who we at intelliCard are, we are a fairly small company, so you might not have heard of us, but we were founded in 2008 here in Switzerland. We're based in Rapperswil, so not so far here from Zurich, and headquartered here in Switzerland, but also with offices in Germany and Sweden. And we provide customers worldwide with fully managed ID security solutions and services. And we're heavily a software development company, developing software for certificate lifecycle management and PKI. And we have very recently started to brand ourselves under ID Security by intelliCard. So in case you're wondering later on why my email says ID Security, that's the brand we're using now as we're focusing on PKI and identity security solutions. And a little bit about myself. My name is Anton Hodell, and I started with intelliCard in 2003, just about 1 year ago. And before that, as you heard, I've been deploying PKI in many different countries, publicly and privately, for the last 8 years. And I'm based out of Stockholm, and I consider myself an automation enthusiast. And what I mean with that is that I really don't want to do repetitive work more than once if I can avoid it. And I'm always looking to explore tools to help me achieve that. Now, for the context of this project that I'll soon describe, it involves our certificate management system, CIMA Certificate Manager, which is a fully featured certificate lifecycle manager, or CLM. And it's a modern one that we developed and released less than a year ago. And it provides a front end to your various public and private CAs that you might have and be using in an organization. It helps you get an inventory of your certificates, your different cryptographic algorithms in use to help make decisions based on that. And it also provides different modern enrollment protocol front-end support. So independently of what your backend CA might support, you have all of your protocols that you might need available through CIMA. And it also helps with notifications and reporting based on all of this data. And since I started working with intelliCard, I was focused on automating the deployment of the software and doing that using tools like Ansible and containers. So that was the main focus of my work for the last year. But when it came to actually configuring the application after deployment, I made use of the web interface, which is a nice modern one, but it's fully based on REST. So I was always curious to see what could be done to automate the work that I had to do in the user interface, but if I could instead script this and apply all of the rules and logic that I might need for setting up a full deployment. So the background of the project that I faced earlier this summer was to migrate 100,000 certificates together with metadata about the certificates from an existing certificate lifecycle management system into CIMA. And in order to do so, I also needed to configure quite a large number of templates to handle all of these certificates, depending on how they were issued initially. And this was also a live CA and live PKI, so it should all be done in a smooth transition to not interrupt the ongoing work of the certificates. And this is not a massive PKI by any means, but it's still a moderately sized PKI. So it's not something that you want to do fully manually. You want to test it properly and make sure that everything works before you actually go through and do such a migration. And some of the challenges faced with this is that if you are familiar with setting up a PKI, you know that there's quite a lot of different configurations and settings that you need to be very well aware of, and that everything needs to be done correctly for things to work. And in this case, there were quite a number, more than 20 at least, of CA templates available and used by the PKI. So everything had to be migrated in a safe and secure way. And also, when doing this amount of configurations, I'm also well aware that there's a risk of introducing misconfigurations if you're trying to do everything manually. So if you manually set something up and it works in a test environment, if you have to do it manually again in production, you might do one small mistake that causes problem later on. So this was also meant to reduce the risk of misconfigurations, to try to automate this, to make sure that it's all done the same in the test and production environment. And you've heard a lot about REST already today, but I just wanted to add a small slide about what the REST APIs are, just in case anyone is not intimately familiar with it already. So REST stands for Representational State Transfer, and it's an architectural style for APIs. So it's not a standard or a protocol, but it's just a style that defines constraints on how you interact with the server. And it's based around a client-server communicating with each other with the use of HTTP calls. Very often, if you're working with REST, you will see something called the Swagger UI, which is a commonly used tool for making REST available to any user. And Swagger UI is a tool that makes interactive API documentation automatically for an application following this specification that is based on called the Open API specification. And you can see here a screenshot of what this might look like. It shows you the different endpoints that the API makes available, what kind of HTTP request you should be making to interact with it. And if you start digging in this interactive documentation, you can see exactly which parameters you can send and what data you get back with this. So REST is based around representational state transfer. You're transferring representations about the resources on the server. And if you are, as you are probably very well aware, REST has been around for a long time, and there really is an abundance of available clients and tools for making use of REST. So pretty much every scripting and programming languages have tools for making use of REST. When I started this project this summer to do this migration, I knew that I wanted to make use of the REST calls for the reasons I mentioned. And my first approach when trying to do something like this is to look at what existing tools are available. So what can I already use that solves my problem? And first of all, the data that I had to migrate was provided to me in the form of CSV files together with the necessary metadata. So I didn't need to think about how I got the data. I just needed to process that data and import it into our certificate manager. Initially, I tried to use an internal Java-based tool that we had that's called the REST script runner, something that our developers make use for configuring system in development environments. And here you can see an example of what that looked like. And it has an XML structure syntax that I found quite difficult to use and difficult to extend and expand on. And also, when I was testing this tool out, I found that the performance wasn't that good. It would take more than 12 hours to import all of these certificates that I had. And I wasn't very flexible using this tool. So my next step was try to see if I could make something using Python, which is my preferred language for development. I'm not a developer myself, but it's a language that I've used a lot in the past for scripting various things, processing data. So I knew that I could really get the full capabilities of the language if I had something in Python. And again, I started to look at what are the tools in Python for using REST. And I found that there is a very popular library just called requests, which is a simple HTTP library for Python that says it's built for human beings, and I'm a human being, so I thought that maybe this is a good tool for me. And the first challenge that I needed to make, since this is very much a high security product, I needed to have a secure connection and authenticate myself in order to use the API. And I wanted to make use of mutual TLS using PKCS12 key stores. And this was not natively supported in the requests library, but fortunately there was an add-on library called requests PKCS12, which added this functionality. Then I also needed to maintain this authenticated session to send my calls after doing the initial login using username and password. And fortunately, all of this was handled by the requests library. So it persisted session with session cookies and did everything I needed. So the code snippet that you see here on the screen is more or less everything I needed for a very basic REST API client. It handled the login session, and it persisted as this SEMA session object that I could then use to send all of the basic HTTP calls. But that's not a very flexible tool, so I set out to make some improvements just to make it easier for me to work with doing what I wanted to do. And to do that, I wanted to abstract all of the commonly used processes and calls that I was making. So an example of how I improved on the tool here is that instead of just having the basic GET request and getting a resource, which is the generic call, I found that I very often wanted to just get an item, like get a template or see a configuration from my certificate manager. So I made a get item call, which takes either a name or an ID of a resource and gets me that object back. But then I found that sometimes I wanted to get items based on other criteria. Maybe I wanted to get all the templates that are of type server certificates or client certificates. So that made me create a get item by key value instead. And this, you might see, is just a more general version of the get item where the key is the name or ID. And similarly, sometimes I want to get all items that follow this rule, so then it's get items instead of get item. So I try to structure my code so that the example here is that the get items by key value calls the basic get request, but then the get item by key value gets all the items with the use of the get items, and then just checks that it got just one item back, because get item means I'm just looking for one item that wants this, that follows that criteria. And if it gets more than one item, then something went wrong. You requested something that does not uniquely identify one item, so it raises an exception in that case. And then the get item call that I initially made a lot of use for, then that could just reference the get item by key value and specify that the key value is either name or ID. And this helped a lot later on when I started to add error handling and debug logging, since I had it so that instead of having every call made specifically, it all made use of a generic requests method, so that by adding some logging to the request method, all of my calls had access to that logging. And I also wanted this tool to be somewhat optimized. So one thing I absolutely knew that I had to do was to add some form of caching, because I found that when importing certificates, for every certificate that had to be imported, it needed to look up the ID of the CA based on the issuing CA name, and the template also based on a template name. So those two calls, where there's not a huge number of CAs and templates in the system, making those calls for every certificate to be imported was not very efficient. So to add caching for that, I looked at if there was something in Python that already solved my problem. And fortunately, there was. It's called a cache decorator, which is this @cache syntax that you see here. So by adding this just on top of my function, which you see here in the top right corner, it adds caching, so that anytime this method is called with the same arguments, it caches the response and uses that cache response instead of having to contact the SEMA server to get the data every time. In order to do this, I needed to know that these IDs, which is where I use this, were stable, so they would not be changing between calls. And yeah, I could be confident about so I added this. And as I would find out by just adding this one line here, including importing the necessary libraries in Python, I was able to double the performance for importing certificates because it avoided doing all of these extra calls for getting data from the server. And for testing performance, I created a small timer decorator myself, which you can see here. So what a decorator in Python is, it's a wrapper function. So it takes the function that you want to use and sends that to the wrapper function, which does something before and after the execution of the function. In this case, it just looks at the time before and after running the function the decorator is on and prints out the result for that. So then I could get very easy performance statistics when running the scripts. And then when I had my tool and I wanted to use it, this is just an example of what this looked like. The idea was to separate logic and data. So I kept all my data in a YAML file, a settings file, so that everything would be reusable in other projects. I didn't want to create a tool that just solves this one specific problem, but it should be more generically usable in the future as well. And as Python, the whole idea was to have more advanced data processing available when I needed it. I had those functions here. So for example, I could send update calls to all templates following matching a certain criteria and do that easily. But that's the specifics I don't want to get into here today. And then when I had done this tool with SEMA and used the API, I started to look at, well, what else can I do with REST now that I'm somewhat more familiar with working with it than I was before. And eDBCA is a product I've used much in the past, and I knew that eDBCA also has a REST API. So I started looking at, well, how can I take eDBCA REST API and SEMA REST API and sort of connect the two. And I started by just creating an eDBCA session object for creating these authenticated sessions, quite similar to what I did with SEMA initially. And then I used the eDBCA REST API for fetching certificates and PKI configurations and converting those into SEMA configurations so that I could automatically have my SEMA instance reflect an already existing eDBCA instance and provide all of the necessary enrollment functionality, certificate inventorying, statistic, etc., fully automatically. So here's a snippet of running that script here. It contacts eDBCA, looks at what's configured there, uses these rules that I need to create for converting the eDBCA way of configuring things to SEMA way, and then applying those. And in about 15 seconds, I could fully synchronize one environment to another. But the project that I was working on during the summer didn't have an eDBCA backend. Instead, it was ADCS, which is you might know as the Microsoft CA. And there is no readily available REST API for interfacing with the PKI. There might be some third-party solutions that provides it, but it seems to be more centered around enrollment and not so much configuration management, which is what I was interested in. But there are certain PowerShell modules and also the built-in certutil.exe, which you can use to dump out your certificates and template configurations for a Microsoft CA. So you can see what those calls look like. And in the example of certutil CA templates export, what you get out is everything in a text file. So this text file here, it contains all the configurations that are on those templates, but it's not so easily machine processable and usable. So I just made a simple tool to convert that into YAML syntax, since that's what I prefer. And then I could use that data to actually configure SEMA again to match an already existing ADCS deployment. And this, it would turn out, was also very useful for validating my configurations that I had applied for this project. Because when I started working on the project, I had various documentation centered around how the PKI was set up, how the templates were configured, etc. But when I started doing this processing, I noticed that there were certain discrepancies. Because, of course, with documentation that's manually created, there's always the risk that it becomes out of date and someone changes something in the software that they don't update in the documentation, or that someone makes a mistake when documenting things. So I noticed that there were some problems with the documentation, and with this I could actually use the real configurations coming from the system itself instead of having to rely on perhaps unreliable documentation. So in the end, my results and takeaways for doing this project was that I think I achieved a faster and higher quality deployments than if I had done all of this manually. And using my tool, the full import of 100,000 certificates or thereabout took just over an hour, so much quicker than at least the previous tool that I have. And all of this was done fully automated. So both the deployment of the software itself using Ansible, and then the configuration using the REST client tool that I created. And as was very important for me was that these scripts and tools that I used are fully reusable for future projects that I need to do. And some of the goals that I now see are very good to have is to, first of all, I want to expand this tool that I have into other scripting languages. So I'm thinking, for example, PowerShell in an environment where you need to use Kerberos authentication, where it's very, very well natively available compared to MTLS. But also to just have this mindset of looking at what other tools offer a REST API, and does it make sense to create a client for interacting with it, even if I'm not a software developer creating this kind of interactions. Now with the next slide, this is just a sort of result slide from doing one of the test imports of the full certificate data. This is our CIMA Certificate Manager dashboard, where I fully set up all of these different statistics. So in CIMA, well, it's a very flexible product where you can set up everything, but now I have some defined rules that gives you a very good basic installation, where it gives you statistics of certificates by template, by which CA issued it, what type of certificate is, which protocol it was issued under. And also you have these counters, which are meant to give you the most relevant statistics. And I figured that in most PKIs where you have a certificate lifecycle manager, you want to know, well, what has been issued, what is about to expire, and when is it expiring, how much has been issued in the past instance, and those kind of things. So I made that now, whenever I deploy something, I have all of this available. I don't need to manually configuring it. It's just there. So quite happy with that. And with that said, I want to thank you for your attention.